Have you ever just looked up at the night sky and wondered how on earth do we measure those insane distances? Well, today we're going to unravel exactly that. We're talking about how astronomers came up with a ruler big enough for the entire universe. So let's get right into it. It really all boils down to this one simple question. But, the answer is anything but simple. Because when we try to use the measurements we're used to here on Earth, like kilometers or miles, we run into a very, very big problem. Just look at this number for a second. That's 40,208,000,000,000 kilometers. And you want to know what that is? That's the distance to our nearest star, Proxima Centauri. When you're dealing with numbers this gigantic, our everyday units, well, they just start to feel kind of useless. And that really gets us to the heart of the issue here. The units we came up with to measure, mountains and the trip to Grandma's house, they just completely fall apart when we point them at the cosmos. Honestly, it's like trying to measure the entire Pacific Ocean with one of those little plastic school rulers. It's just not the right tool for the job, right? We need a completely new kind of ruler, one that's actually built for the mind-boggling scale of space itself. So what is this cosmic ruler? What did we come up with? Well, astronomers found their answer in literally the fastest thing in the entire universe. They decided to build a ruler made of pure light. They called it the light year. And here's the definition, and it's so beautifully simple. A light year is just the distance that a beam of light can travel in one single year. That's it. But because of its name, this super simple definition leads to a really common mix-up. Okay, so let's clear this up right now, because this is the most important part. Because the word year is in the name, so many people think it's a measure of time. It's not. A light year is a unit of distance, just like a kilometer or a mile, but on a scale that is almost impossible to imagine. Now, to really wrap our heads around the sheer size of a light year, we have to understand its main ingredient. It's all built on what we call the cosmic speed limit, the speed of light. And this isn't just fast, it is the absolute, unbreakable speed limit for everything in our universe. Light moves at nearly 300,000 kilometers every single second. As far as we know, based on all of our physics, nothing with mass can ever reach this speed. It is a fundamental constant of reality. Now, to put that huge number into perspective, think about this. In the time it takes you to snap your fingers, 1 second, a beam of light could whip around our entire planet 7.5 times. That's the kind of speed we're dealing with here. It's just incredible. So how do we build up to that colossal distance? Well, you can see it here. We start with a light second, right? That's our 300,000 kilometers. Then we can calculate a light minute, then a light hour. And when you let that beam of light travel for one full year, you finally get there. 1 light year is about 9.5 trillion kilometers. Okay, so we've established the light year as a unit of distance. Got it. But because it's based on light, and light takes time to get from place to place, it has this profound, almost magical consequence. And this is where we get to the idea of taking a journey back in time. This is one of those ideas that just changes how you look at the night sky forever. Because light isn't instantaneous, the light from that star you're looking at had to travel for years, or centuries, or even millions of years to finally reach your eyes. So in a very real way, every telescope is a time machine. And this table just lays it out so perfectly. The sunlight warming your face right now? Yeah, that's over 8 minutes old. The light from Alpha Centauri, our closest stellar neighbor? It left that star almost 4.5 years ago. And the Andromeda Galaxy, the light you see from it tonight, started its journey 2.5 million years ago. Modern humans weren't even a thing yet. So really, when you're looking up at all those stars, you're not just seeing lights in the sky. You are looking at a history book. And every single star is a different page from a different chapter in cosmic time. So this incredible tool, the light year, lets us do so much more than just measure distance. It lets us measure history itself on a scale that's almost too big to comprehend. And the range of this tool is just what makes it so amazing. I mean, we can use it for the tiny 1.3 light-second trip to our moon, all the way up to the 100,000 light-year span of our own Milky Way galaxy, and even to the very edge of everything we can see, a staggering 46 billion light-years away. So you see, a light-year is so much more than just a number. It's It's a story. It's a story of a journey. It's like a message in a bottle sent from a star that might not even exist anymore, a perfect snapshot of the universe, frozen in time and delivered right to us. And I just want to leave you with this thought. The light year proves that even though we're just tiny specks in this vast, vast cosmos, our minds, our curiosity, and our desire to understand it all is truly enormous. It's just a beautiful reminder that we're all born explorers, always reaching for that next distant star.